Hello, it's Marcus Cattani here. I'd like to talk to you about my research project concerned with forecasting injury risks. I'll give it a bit of a background, show what we've been doing, and some of the future ideas for this project. I've chosen this title to make a distinction between prediction and forecasting. Prediction really means that we have a known outcome with quite specific times or locations, whereas forecasting is more to do with probability. So for example, I'm fairly sure we cannot predict that on a certain date or a particular time an incident will occur. But I'm fairly certain we can forecast how likely an organisation is to have an injury and maybe what we should do about it. As a bit of background, there's some frustration at the moment about occupational health and safety performance, or in particular, incidents and injuries. Several authors, including Professor Sidney Dekker, have described a plateau in performance recently. So over the last 10 or so years, maybe since 2000, there's been a reduction in the rate of improvement. And so the search is on for a solution. That is, how can we improve our safety performance and stop so many people getting hurt? And I think everybody agrees there's obviously something not quite right when so many people are getting hurt and the impact on the economy is so huge. In fact, the cost is around 4% of global GDP and about 4% of Australians' GDP too. And if you have a look on Google, as I did, the global number is around $3 trillion. So even if we can only make a small difference, we can have a major impact both on the health and safety of individuals and the impact on the economy. Also, some of these numbers are likely to be a slight underestimation, as not all countries have reliable safety data. So there's a lot of difference between different countries, but also between different industries. The oil and gas industry, for example, have made an outstanding progress on their safety performance, in particular since the Piper Alpha incident in 1988, where 167 people were killed. The resulting inquiry had a major impact on the industry. In particular, the inquiry recommended changes in the offshore oil and gas safety legislation. These changes included the requirement for an organisation which proposes a new oil rig or facility to develop a safety case. That is, they must show they've developed a safety management system which demonstrates an acceptable level of risk before they're given permission to build their oil rig. And then their performance is regularly reviewed by the regulator to ensure they are effective on an ongoing basis. So if you imagine how much money is at stake from the oil rig, and they can't start to produce that or even build that oil rig until the regulator gives them the go-ahead, it gives a great deal of emphasis on safety and safety performance to the leadership teams. And this is an important point in improving occupational health and safety performance. So, as you can see from this extract from the regulator's annual report, they didn't have any fatalities in the offshore oil and gas industry in Australia in the 2016 reporting period. And importantly, they didn't have any serious or major investigations either. So when an organisation in the offshore oil and gas industry has a major incident, they have to report that, and then the regulator will go and inspect and conduct an investigation. So they didn't have any of those either. So there's been a tremendous improvement in the performance from 1988 until 2016-17 in the Australian oil and gas industry. My suggestion is that the requirement for an organisation to gain approval for their new facilities safety performance before they go ahead and build it has had a major impact on the safety performance in the oil and gas industry. And my research aims to see if we can provide similar information to the leaders of other non-oil and gas industries and organizations so they can make decisions on how to manage risk before something goes wrong. So I wanted to see whether we can find a way of analysing data and information to determine the level of risk in an organisation, and then evaluate that level of risk to see whether it's acceptable or not, following the ISO 31000 risk management process and terminology. As in many jurisdictions around the world, there's a requirement in Western Australia for organisations to inform the government of significant incidents. And so over the years, the government departments, so the Mines Department and WorkSafe and WorkCover, have collected large databases of incidents and injuries. My hypothesis was that these incidents could give us an indication of the level of risk in those industries and in those organisations. So, for example, if an organisation tends to report lots of injuries, this would indicate the level of risk is higher than if they reported very few. There's been some excellent work in Western Australia to review the data from the Mines Department and other departments. For example, the government has shown that 60% or 70% of the fatalities appear to have occurred when the supervisor has less than 2 years' experience. And recently, the Fatalities Risk Register, which have been compiled from the fatality reports, provides an excellent free resource to indicate to organisations how we can learn from incidents. I asked the Mines Department and WorkCover for access to their data, and after getting ethics approval, I started to review these databases to see whether I could develop some sort of risk forecasting algorithm. So I had a look to see whether I could review this data to see whether there was anything in there to help us understand what could be happening in the future. Would it be possible to forecast the future injury risk reliably and then assist organisations with some recommendations to make improvements in a similar way as the oil and gas industry reviews their previous oil rig performance data and design data and use that to help build the next oil rig. So I was driven by the idea that past performance should be able to help us with highlighting areas of improvement for future performance. So I developed an algorithm to convert the data and information I had into an injury risk profile score. And I calculated this score over time. I looked at the changes in the profile over time and developed a series of scenarios to try and explain these changes. So if an organisation had a series of injuries, such as in the yellow band on the slide, in 1 year but not the next, that told me that they'd increased their effectiveness of controls. Then I looked at their effectiveness of controls over a huge range of other categories of data from the database, such as the hazards, the injured person's job description, the severity, the body part, the location, and so on. And I challenged the data to see if I could create a more detailed role profile, not just of the incidents, but the effectiveness of the organisation's control of incidents over time. So I used the language from the occupational health and safety management systems to help communicate the requirements for the algorithm. I created around 200 different variables which are mapped to a whole series of elements from the Department of Mines and WorkCover data, which has helped me create a series of functions within the algorithm that allow me to understand how effective an organisation is over time in responding to a particular incident. So not only have they got to design effective actions in response to a series of contributing factors, they've got to sustain those actions over time. So if we saw changes in performance, so they may be effective in 1 year at controlling a particular injury or incident, and then not the next, then we've got an understanding that those actions may not have been effectively designed. And this has given me the opportunity to sort of slice and dice the data in many ways to build up a profile from a whole series of different incidents and get some sort of detailed understanding of that organization's ability to design and implement and sustain actions over time. So, but unfortunately, the data that I had from the government didn't give me enough information about specific organizations. So I asked industry for some data, in particular their risk register data, their action management data, some information about their safety management systems and so on. And a construction organization with many sites around the world gave me access to their data. And we used the algorithm to create a risk profile for each of the years. So that's the green line that you can see on this slide. So then we tried to develop a way of continuing the green line into the future. So we developed a statistical forecasting process using some modern statistical techniques. And the blue line on this graph shows how our algorithm, our forecasting algorithm, predicted the level of risk into the future. And when we compared that forecast level of risk in the future to the actual, we saw a surprising observation that the first couple of years were actually quite close to what had actually happened. But then there was a big reduction in 2014. Now, when we looked at the data, we had a very good idea of why that had happened, because in fact that organisation had a fatality sometime in 2013, and they've had a huge focus in the business on ensuring that that wouldn't happen again, and a pile of initiatives to improve their safety performance. But we thought that if the organisation had known about the increase in risk that we'd forecast, then they probably would have had the opportunity to do something about it. And we presented this information to the board of the company, and they were they basically said that if they'd known about this change in the level of risk, it would have given them a great opportunity to do something proactive about it. So we thought, well, if that change in the level of risk would have been useful to the company, we'd concentrate on providing a mechanism for giving organisations an opportunity to proactively put in place some risk management processes. So we created an idea of an alarm relative to a series of risk criteria, referencing ISO 31000. So we used our risk profiling tool relative to a couple of risk criteria, and then if the forecast indicated the level of risk went above those criteria, an alarm sounded. And since we had a pretty good idea of why the alarm was sounding, we can also develop a series of recommendations to address that increase in risk towards the alarm. And so we can provide some recommendations to assist the organisation to manage that. When I spoke to the government about this idea, they thought it was a great idea and gave me some funding to assist communicate this.
Did you know that in Australia, an MCG full of people get seriously injured every year? In 2013, the costs were estimated at $61.8 billion, and two-thirds of the costs go to manual handling injuries. Unless your organisation is actively preventing injuries, you can't expect change. Organisations can improve their productivity by saving on unnecessary costs associated with injuries. We've come up with Injury Alarm, an algorithm which tells you the likelihood of an injury occurring within your company. It's like installing a fire alarm in your company. If the fire alarm goes off, you evacuate. Injury Alarm won't make you leave the building, but will prompt you to prevent an injury and turn the alarm off. We can help you save money, increase productivity, and prevent hospital beds filling up. Tell management about Injury Alarm and the benefit to preventing injury in your company. Try the free version of our application now.
So Injury Alarm was launched by the Minister responsible for occupational health and safety in Western Australia on World Safety Day 2017. We didn't have a great deal of time when we found out about World Safety Day, so the version online at the moment is a cut down version just to raise awareness of this new process and try to get some interest from industry. We've got 2 or 3 new versions lined up, which we hope to launch once we achieve some funding, and I'll let you know about that in a moment. But we've had quite a lot of success with Injury Alarm and hope to develop it in the future for industry to use to give them a proactive understanding of how they can manage their risk into the future. So just to finish off, the Injury Alarm process allows organisations to understand the answer to this question about what is my injury risk, how likely is an incident, and what do we need to do to improve. So at the 9 o'clock position there, if we put the organisation's safety data into Injury Alarm, we can come up with a series of recommendations on how to improve. But those recommendations may need some technical skills and some understanding, some leadership training and so on. And so we've developed a series of injury risk management training. The government have given me the opportunity of doing some research with over 3,000 people, or 3,000 questionnaires have been provided at the various events, and we're analysing that to create some training materials that respond to the risk-based requirements of the new legislation. And the university has integrated the risk management and risk communication process into a series of undergrad and postgrad units. There's some participation courses available and a certified course available through some registered training organisations. So once you complete that training, you can go back to the beginning and ask whether your organisation has adequately managed their injury risk. Now we're going to try and raise some money for the ongoing development of the research centre so that we can continue to improve Injury Alarm. So if you'd like your data to be analysed using the Injury Alarm process or the next risk forecasting process, let us know, and you can be part of this research programme. So in conclusion, we think we've developed a useful leadership information tool to enable proactive action to be taken to improve the management of risk. We need to test this process over and over again with additional data sets. So I'll be very interested to hear from you if you would like to donate your data in return for us to giving a report And we're aiming to automate the more detailed process, so version 2 of Injury Alarm can come along, in particular to develop the recommendations. If you'd like to sponsor the research, please let me know, and I'd be grateful to talk you through it. Okay, thank you very much.